Hey yo, what up? It's your boy, Mr. Oldridge, aka Chemist Nate, aka the Trapper of the Century. Today we're going to be converting decimal numbers into binary numbers. Binary means it's only made of ones and zeros. So you either have a 1 in that column or you have a 0 in that column, and that's it. Whereas with decimal numbers, every digit in a decimal number goes from 0 to 9. In the case of 341, you have a 3 in the hundreds column, a 4 in the tens column, and a 1 in the ones column. The difference with binary, the rightmost digit here is still the ones column, but instead of it going tens, hundreds, thousands, you're going to double each time instead. So this is the twos column, the fours column, the eights column. Note that if you had a 1 in the twos column and a 1 in the ones column, that would only add up to 3. And if you ever want to get to actual 4, you'd have to notch this up to 1 and then zero these out. I'll show you what I mean in just a second. Let's convert 341 to binary. Where's my palette of colors here? There we are. I'm going to use red. I'm going to use a pen. Okay. The question I want you asking yourself is, how many times does 2048 go into 341? Well, 2048 is too big, so it's nothing. Oh, I don't know if this... Oh, there we go. I put a 0 in there. You can't fit any of those in there. Can you fit 1024 into 341? No, you cannot. How about 512? No, you cannot. How about 256? The answer is yes, you can fit one 256 into there. When you take 256 away from 341, you can use a calculator to get that. You're going to end up with, 985? Something like that. So you have 85 left to account for. Can a 1 in the 128 column help with that? No, 128 is too big, so put a 0 there. But you can fit 64 into what's left over. You can now take 64 away from this. We're going to be left with 21, so we need to account for 21 more. 32, too big. 16, just right. Well, actually not just right. You can fit one in, and you take the 16 away, and you end up with a leftover of 5. Can an 8 fit in there? No. Can a 4? Yes. Take 4 away. You're going to be left with a single 1. 2 is too big, and 1 is finally just right. And then when you take away that 1, you have no remainder. The idea here is that the binary version of 341 is 101010101. Okay, I didn't mean for it to alternate ones and zeros like that. That's a coincidence. I just picked 341 out of my butt. But hey, it worked, right? Let's do it again for a bigger number. How many times can 2048 go into 2341? Once. All right, so now your job is to take 2048 away from this. And I believe when you do that, you get 293. Great. Use your calculator if you're not as stellar at math as your boy. Will 1024 fit into the leftover 293? No. What about 512? No. What about 256? Yes. You get where we're going with this? So you take away the 256 that you just accounted for by putting a 1 in that column. The leftover here is 37. Will 128 help? No. 64? No. 32? Yes. Take 32 away. You're going to be left with 5. We've seen this before. A 5 is a combination of the 4 and the 1. And the rest of them are zeros. You can have done that the regular way too. 16 doesn't fit, 8 doesn't fit, but 4 does, leaves 1 behind. Great. So the binary version of 2341 is 100100101. It also felt repetitive, but it's a It's a coincidence. Okay, so as long as you memorize this chart thing that I've done here, and I'm not giving you that on tests, so learn it. Start with 1 and double the value of the column every time you go by. And then see how many of each of those you can fit into what's left of the decimal number you were given. Cool? Cool. Binary to hexadecimal is going to work the same way. If some teacher in your future asks you about decimal to octal, it's going to work similar to that. It's going to be lots of practice in your future. See you there. Best of luck.